Welcome dear students to this program. Dear students, today we are going to discuss about Herons formula, that is in chapter 12 of class 9 mathematics book. This is the part 1 of Herons formula. Before going to discuss about this Herons formula, we will consider about the perimeter and the area. What do we mean by perimeter and area? These two are terms associated with the closed geometrical figures. In closed geometrical figures, we have two types of numbers, and these are our perimeter and area. And what is perimeter? The length of the boundary of the closed figure is known as the perimeter of a figure. Now, if the closed figure is a triangle, then what will be the perimeter of the triangle? Yes, the boundary of the triangular region is the sum of the three sides of the triangle. Similarly, we also associate with the region inside the closed figure, and that measurement is known as area of region bounded by a closed figure. So, when we consider the area, then how to express it? Earlier, you have discussed all these things about area. Let's recapitulate it. And what is it? You see, in this figure, a square is divided into some small squares. And if we take this length and breadth of this small square as 1 unit, then in here we have 4 units of length of the side, and in vertical also we have 4 units of length. So, how many squares are accommodated in this large square? If we consider these small squares as 1 unit square, then how many units are exist in it? You see, in first row we have 4 squares, in second row we have again 4 squares, and also in next rows in two rows we have again 8 squares. So, in total we have 16 squares. Now, as 16 squares are there, so we can say the area is 16 square units. Let's have a look at a rectangle. Here in this figure we have a rectangle. Why it is rectangle? Because in lengthwise here it is 4 units, and in breadthwise here it is 3 units. So, how many small squares, unit squares are accommodated in it? You see, in first row 3, in first row 4, in second row 4 squares, and in third row also 4 squares, in total 12 squares. So, we can say that area is 12 square units. Now, you see, in length it is 4 units, and in breadth it is 3 units, and the area is 12 units. So, we can say that area of rectangle is equal to length into breadth, that is 4 into 3 square units. So, in case of rectangle we have a formula, that is area of the rectangle is equal to length into breadth. Let's see, here ABCD is a rectangle, and AB and BC are respectively breadth and length, and you see the length and breadth are two consecutive sides, AB and BC. So, we can say area of this rectangle is AB into BC. If we draw a diagonal AC, then what happens? This divides the rectangle into 2 equal parts, and each equal part have the area that is half of the area of this rectangle. So, as this ABC is half of it, and you see what type of figure is it? It is a right angle triangle. So the right angle triangle ABC has area that is half of the area of ABCD. Now we can say that area of right triangle is half into AB into BC. And what is AB? If we consider it to be right triangle, then AB is said to be height and BC is said to be base. Alternately, we can also say that BC is height and AB is base, but here we have taken AB as the height and BC as the base. Now you see, if in this figure ABC is a right angle triangle, then we can have another triangle DBC with the same base and same height. So DE is equal to AB. In this case, the area of triangle DBC is also same as half into DE into BC. That is, what is DE? DE is the height of the triangle DBC and BC is the base. So this is very popular formula. As you know that area of triangle is half into height into base. So if all the three sides are given, can we find the area of the triangle? Let's see. In case of area of an equilateral triangle, when all the sides are given, let's have a look at this figure. This is an equilateral triangle ABC. Each of side say 10 centimeter. Then what will be its area? As we know, to get the area we need the height. If we draw the height or perpendicular from A to BC, say AD, then AD bisects BC. As AD bisects BC, then BD is 5 centimeter. Now you see, in right triangle, ABD, by using Pythagoras theorem, we can say that AD is equal to square root of AB square minus BD square, because in ADB right triangle, AB is the hypotenuse and BD and AD are the other sides, and from this we get AD is equal to square of AB minus square of BD. Now you see, what is AB? AB is 10, so 10 square is 100, and what is BD? BD is 5 and its square is 25. So square root of 75, that is, this is again 25 into 3, and square root of 25 is 5 and square root of 3 is 3. So this much centimeter. Then what is area? So in this case, what did we do? We have to find the height. Because of this peculiarity of this triangle, it is easy to find the height. So from this we have half into AD into BC, and see half into what is AD? AD is 5 root 3 into what is BC? BC is 10. This gives 2 and this becomes 5. So 25 root 3 square centimeter. Now see, in this case it is very easy as it is a equilateral triangle. Now what about the isosceles triangle? Area of an isosceles triangle when length of each side is given. Let's see another problem. If we take an isosceles triangle whose equal sides are say 5 centimeter and the unequal side to be 8 centimeter. We can draw a perpendicular. So, in ABC triangle, this is our D. Now, as you know, in isosceles triangle, if perpendicular is drawn from the vertex to its side, unequal side, then it bisects it. So, BC is bisected by AD and BD is equal to DC. So, BD equal to 4 centimeter. Again, as in previous case, in triangle ABD, angle D is 90 degree. So, this is right triangle and AB is the hypotenuse. So, we can find AD is equal to square root of AB square minus BD square, that gives square root of AB square is means 5 square, that is 25, and square root of BD, that is 4, square of 4 is 16, that is square root of 25 minus 16 gives 9, that is 3 centimeter. Now, AD means height is 3 centimeter and base is 8 centimeter. So, area of the isosceles triangle is equal to half into BC into AD, that is half into BC is 8 and AD is 3, that is 12 square centimeter. So, in this case also we can find the area of the triangle if all the 3 sides are given. Let us come to another triangle, that is area of a scalene triangle when length of each side is given. Let us get a scalene triangle whose sides are say 40 centimeter, 32 centimeter and 24 centimeter. Can you find this height or this height or this height? It is not so easy to get the length of the height in case of a scalene triangle. So, how to find the area of this scalene triangle? So, this is done by the famous Herons formula, which is discovered by the great Greek mathematician from Alexandria, Heron, who has immense effort and contribution to mathematics, and his formula says square root of s into s minus a into s minus b into s minus c. What is a, b, and what is a, what is b, and what is c? These a, b, c are the sides of a triangle. Then what is s? S is half of a plus b plus c. That is, what is a plus b plus c? That means length of the 3 sides of a triangle. What is it called? It is called perimeter. So, half of the perimeter, that is, we say that it is semi-perimeter of a triangle. So, we know what is S, A, B and C. So, the formula is square root of S into S minus A into S minus B into S minus C. Using this formula, let us try to solve these problems. After getting this formula, can you now find the area of a triangular park whose sides are 40 meter, 32 meter and 24 meter? Let us see how to do it. As you know, this is a triangular park. So, we can write the sides as A equal to 40 meter, B is equal to 32 meter, and C is equal to 24 meter. So, S is A plus B plus C by 2, that is 40 plus 32 plus 24 by 2, that is 96 by 2, that is 48 meters. Then what is the area? Area is equal to square root of S into S minus A into S minus B into S minus C. Now see, this is square root of 48 into 48 minus 40 into 48 minus 32 into 48 minus 24. We can write this as 48 into 48 minus 40 gives 8, 48 minus 32 gives 16, and 48 minus 24 gives 24. If you solve this, we can get 384 meter square. That means the area of this park is 384 meter square. If we look at these figures, that is 40, 32 and 24, we can say that 32 square is 1024 and 24 square is 576. If you add these two, this is 1600, which is same as 40 square. Here sum of two squares is equal to the third square, so this constitutes a Pythagorean triplet. That means 40 is the hypotenuse and 32 and 24 are the height and base. So from that angle we can also find the area of this triangular field, that is half into 32 into 24, and this also gives 384 meter square. That means what we got in Herons formula, we also find it from the basic formula, that is half base into height. Let's see another problem. In this case, equilateral triangle, as we have done already by using half base and height, let's try it with Herons formula. As it is equilateral triangle, so we can say A is equal to B is equal to C equal to 10 centimeter. In this case, S is equal to A plus B plus C by 2, that is 10 plus 10 plus 10 by 2, that is 30 by 2, that is 15. So area of the triangle is equal to square root of S into S minus A into S minus B into S minus C, that gives square root of 15 into 15 minus 10 into 15 minus 10 into 15 minus 10. That gives 15 into 5 into 5 into 5. You see 15 is same as 5 into 3, so we can write 5, 3 into 5 into 5 into 5 into 5. So in place of 4 5s, we can take 5 into 5 and 1 3 remains, so we can write root 3, that is 25 root 3. Earlier we have also found that the area is 25 root 3. Now what is in case of isosceles triangles, what we have taken already using the basic formula. As we discussed about the isosceles triangle, this is the isosceles triangle with 5 centimeter two sides and the third side is 8. So A is equal to B is equal to 5 centimeter and C is 8 centimeter. So S is equal to A plus B plus C by 2, that is 5 plus 5 plus 8 by 2. So here it is 18 by 2, that is 9 centimeter. And what is the area? Area is square root of S into S minus A into S minus B into S minus C, that gives S equal to here 9. So 9 minus 5, again 9 minus 5 and 9 minus 8. This gives square root of 9 into 4 into 4 into 9 minus 8 is 1. You see 9 is square root of 9 is 3 and square root of 4 into 4 is 4. So we can say 3 into 4, that is 12 square centimeter. As earlier we had the area as 12 square centimeter. So here also by using Herons formula we got the same result. Now let's see another problem. This problem says that find the area of a triangle, two sides of which are 18 centimeter and 10 centimeter and the perimeter is 42 centimeter. In this triangle, two sides are 18 centimeter and 10 centimeter and perimeter is 42. That means A is equal to 18, B is equal to 10 and A plus B plus C is equal to 42. From this we get, if we substitute the values of A and B, we have 18 plus 10 plus C is equal to 42. That gives C equal to 42 minus 28, that gives 14. Now you see the third side is 14 centimeter. What is S? S is here semi perimeter, that means perimeter by 2, that is 42 by 2, that gives 21 centimeter. Then what is the area? Area is square root of S into S minus A into S minus B into S minus C. What is the value of S? The value of S is 21. So 21 into 21 minus A is 18. Again 21 minus B is 10 and 21 minus C is here 14. So this gives square root of 21 into 3 into 11 into 7. Now you see here 21 is 7 into 3. So we can write this as 7 into 3 into 3 into 7 into 11. If we rearrange this like this, we have 2 7 and 2 3. For that, in square root we have 7 into 3 into square root of 11. That is 21 square root 11. So the area of this triangle is 21 square root 2 of root 11 of that is 21 root 11 square centimeter. So by using Herons formula we can easily find this area. Now let's see another question. This question says that sides of a triangle are in the ratio 12:17:25 and its perimeter is 540 centimeter. Find its area. You see the ratio, that is A is to B is to C, are in ratio 12:17:25. So we can take A equal to 12x, B equal to 17x and C equal to 25x. Then what is perimeter A plus B plus C? This gives 12x plus 17x plus 25x, that is 54x. Now, but given that the perimeter is 540 centimeter, so 54x equal to 540 centimeter. This gives x equal to 540 by 54, that is 10 centimeter. Hence, A is equal to 12 into 10, that is 120 centimeter. B is equal to 17 into 10, that is 170 centimeter. And C equal to 25 into 10, that is 250 centimeter. Now we got ABC. Now what is S? S equal to perimeter by 2, that is 270 centimeter. Once we got A, B, C and S, we can easily find the area by using the Herons formula. What is that? So area is square root of S into S minus A into S minus B into S minus C. Now you see S is 270 and 270 minus A is 120. Then 270 minus B is 170 and 270 minus and C is 250. This gives the 270 into 270 minus 120 gives 150. 270 minus 170 gives 100 and 270 minus 250 gives 20. So, if we rearrange this, we have 27, that is 3 into 3 into 3, and let in place of this, for this 0, let's write 10, and for 150, 3 into 5 into 10, 100 is again 10 and 10, and in place of 20 we can write 2 into 10. Now from this, what did we get? We have here 1, 2, 3, 4, that is 3 into 3, and how many? 5 into 2, again it gives 10. So how many 10s are here? You see 1, 2, 3, 4, 5 and 6. So we can take 310. That gives 9,000 square centimeter. So dear students, today we discussed how to find the perimeter of a triangle, and then using the perimeter of the triangle, how to use the Herons formula. And Herons formula is used when only 3 sides are given. If height and base are given, we can use the basic formula, that is half base into height, and if the sides are given, then we have to use the Herons formula, that is square root of S into S minus A into S minus B into S minus C, where S is the semi-perimeter, that is A plus B plus C by 2. Hope you understand this discussion. Have a good day. Thank you.